Hello, in this video, we're going to be looking at lesson 8.3, which is on solving right triangles. If you haven't already completed 8.2, you should do that first because this lesson depends on a basic understanding of lesson 8.2 with the trigonometric ratios. This is another 2-day lesson. In this video for day 1, we are just going to focus on the first essential question, which is how do you use trigonometry to find missing angle measures in a right triangle? In the day 2 video, we'll then look at how we can use trigonometry and inverse trigonometry to find all of the missing parts in a right triangle. So let's go ahead and get started. How do we use inverse trig to find angle measures? We're going to actually start the problem off in the same way that we did in 8.2. We're going to label the sides of the triangle in relationship to the angle that we want to find. The sides are hypotenuse, opposite, and adjacent. I like to do the hypotenuse first, the opposite second, and then save the adjacent for last. Then you're going to use the two marked sides and determine which trig ratio to use. You'll ignore the side that's blank. You'll then write a trig ratio equation. But to solve that equation, you have to use an inverse trig function to find the missing angle measure. The inverse trig functions are sine inverse or inverse sine, inverse cosine, and inverse tangent. So that little -1 power means inverse. To get to this on your calculator, you hit the second button, followed by either the sine, cosine, or tangent button. And I'll show you how to get to those shortly. When you're doing this, you can either use a scientific calculator or a graphing calculator. We do need to make sure, though, that our calculator is in degree mode. It needs to be in degree mode or you will get the wrong answer. I went over how to put your calculator in degree mode in the previous lesson, but I will show that here again in a minute. First, let's just practice this first one. So to get an inverse sine, we need to click the second button on our calculator, followed by the sine key. So here are the buttons that you'd push. Second, and then the sine button. And you'll notice that above the sine button, you're going to see that little sine inverse symbol. And then on your calculator screen, you should see this pop up with a parenthesis. Inside the parenthesis, you need to type 4/11, and the fraction bar is just the divide button on your calculator. To get to the online calculator, you can go to the resource folder on the Schoology page and then click on the online calculators link. I think it works best if you open it in a new tab, otherwise it can be kind of glitchy. I like the graphing calculator better, but this also works on a scientific calculator and it's the same buttons. So I'm opening up the online graphing calculator. And once you get there, you have to click this TI-84 graphing calculator link button right there, and that'll make your calculator pop up. Before we do our calculation, we need to put the calculator in degree mode. Every time you open it, if you're using the online calculator, it's going to default to radians. So if I click my mode button and I scroll down to like the 4th line there where it says radian or degree, move the cursor to degree, and then scroll away from that, and it should now be highlighted. Then you can go second mode to quit and go back to your home screen. Now let's type in the inverse sine of 4/11. To do that, I'm going to click the second button, followed by sine, and then 4 divided by 11. Close your parenthesis, hit enter, and there is our value. We're going to round that to the nearest degree, which is the nearest whole number. So if I look at the first number in the second decimal place, it's a 0.3, and anything 0.4 or less rounds down. If it's 0.5 or more, it rounds up. 3 rounds down, so it's going to stay as 21 degrees. So just to recap what I just showed you on the screen, my calculator gave me 21.32. We want to round to the nearest degree, which is the nearest whole number. And a 0.3 rounds down. So we're going to say 21 degrees. Let's try the next one here. And I'm going to just go straight to typing this in my calculator. Now let's do the inverse tangent of 13.6 divided by 7.8. If you still have your calculator open, you should already be in degree mode, so you only have to do that the first time you use your calculator. But if you close it again, if I were to shut the tab and reopen it, then I would have to do it over. I'm still in degree mode, as you can see, so I'm going to go back to my home screen and then do second tangent. And then we have 13.6 divided by 7.8. Close your parenthesis, hit enter, and there we have it, 60.16. And we'll round to the nearest degree. That'll round down with the 0.1, so we'll have 60 degrees. Now for our final example, we'll do the inverse cosine of 16 over 40. So I'll go second cosine button. You'll see inverse cosine, and then we have 16 divided by 40. And we have 66.4, which would round down to 66 degrees. Now that we know how to operate the sine, cosine, and tangent inverse buttons on the calculator, we're ready to try this example. For the triangles below, we're going to label the sides, identify which ratio we will be using, and solve for the given angle. We'll round to the nearest degree, just like we did in example 1. The first thing we need to pay attention to is which angle we want to find. Here we want to find the measure of angle B. So we want to label the sides in relation to angle B. I'm going to start by labeling the hypotenuse, which is across from the 90, and then we'll do the opposite, which is across from the acute angle B, and then adjacent is the only side that's left. There's 3 sides there. We want to ignore the blank one and just focus on the 2 that have the values, which are the hypotenuse and the opposite. Now think back to your trig ratios. Remember, we have the acronym SOHCAHTOA. I think it's helpful just to write that at the top of the page. And the one that uses the H and the O is the sine ratio. That's the SO of SOHCAHTOA, so we'll be using sine. Now we can set up our trig equation. And here I'm just using the steps that were written at the beginning. So we started off by labeling the sides, determining which trig ratio to use, and now we write the trig equation. So I have the sine of angle B, so sine B equals, and then it's O over H, so opposite is 32, and hypotenuse is 45. We want angle B, and to get the B out of the sine function, we're going to use the inverse sine function. So to get this, we do the measure of angle B equals, and then I'm going to do inverse sine, and then in the calculator, you're going to type the ratio, just like we did in example 1. And what that does essentially is it takes the angle out of the trig function and gives us the value. Make sure that you are still in degree mode. I am still in degree mode, and now I'm going to do my inverse sine, so second sine, and then we'll type 32 divided by 45, close your parenthesis, hit enter, and there we have it, 45.3, which will round down to 45 degrees. Let's try another example. For problem B, we want to find the measure of angle A. So the first thing I'm going to do is circle angle A and then label my sides in relationship to angle A. I like to start with the hypotenuse because that is always across from the 90. Then do the opposite. You go to your acute angle A, you go directly across. It's going to be the leg that's not touching A, which is the 9. And then adjacent is the one that's left, the leg that's touching your angle. Now let's focus in on the two marked sides, which are opposite and adjacent. And if we go back to our trig functions, our SOHCAHTOA at the top of the page, we need to use a tangent ratio. So I'm going to set up my equation. Tan of angle A is equal to opposite, which is 9, over adjacent, 15. Now, once again, to get the angle out of the trig function, we need to use an inverse trig function. So the measure of angle A is going to equal the inverse tangent, or tan inverse, of 9 divided by 15. And you can go ahead and type that in your calculator. And when you do that, your calculator will give you 30.96. We want to round to the nearest degree, and 0.9 rounds up, so that 30 is going to become 31. So angle A is 31 degrees. All right, in the next example, we want to find the measure of angle D. So as usual, I'm going to start by labeling my sides. The hypotenuse is across from the 90, that's the 3 meters. Opposite is across from angle D, that's the blank side. And adjacent is the only side that's left. Notice that we have an adjacent and we have a hypotenuse. So if you go to your SOHCAHTOA, the one that uses A and H is the CA of SOHCAHTOA, meaning we need to use cosine. So the cosine of angle D is equal to the adjacent, 1.25, divided by the hypotenuse of 3. Don't worry about the units. They're not going to affect anything in your calculator. So you can just type it like that. And now to get the angle D, we're going to use the inverse cosine. And then in the parentheses, we're going to type 1.25, divide by 3, close our parentheses. And when we do that, the calculator gives us 65.37. The 3 here rounds down, so it's going to stay as 65 degrees. Okay, there is your solution. You should have used the cosine because 15 is adjacent and 17 is the hypotenuse. So the cosine of angle I is equal to 15 over 17. You can do the inverse cosine of 15 divided by 17, and you'll end up with 28 degrees. Finally now, for some things to remember or tips, I want you to remember that to find an angle, you're going to use either sine inverse, cosine inverse, or tangent inverse. Where if you want to find a side, like we did in the previous lesson, then we use the regular sine, cosine, or tangent button and solve with cross products. So we only use those inverse buttons if we're finding an angle. If we know an angle and we're trying to find a side, then we use the regular sine, cosine, and tangent. That's it for day 1. I will continue the rest of the examples in the 8.3 day 2 video. Thanks for watching. Bye.